Hello Techno, how are you doing? Great to see you back. So yeah, we're going to use this cookie. Let me bring back my reference image. Just drag, drop like that. And see, there's nothing special about this. So I'm just going to extrude this using E, shade smooth, and add a subdivision surface modifier like that. Okay, see, having some sharp edges here, but that's okay since we're going to be using a displacement modifier to displace everything. So we can add the displacement modifier, go to the textures and create a cloud texture. Then we can go to the, first apply the scale, reduce the strength. Now, before we even do that, we can add a smooth modifier so that we get much smoother mesh. So let's see. Maybe we can even add a subdivision there. This will kind of round the shape just a bit more. Then we can add the subdivision surface. Then the displacement. Just going to increase the viewport here to 2. Just play. We don't want too much displacement in this. Most of it will be done using the bump as displacement using the nodes here or in the material. So now let's create a procedural texture for the cookie and a high resolution image for this. Okay, this is really high. Fine. Something. Okay, I need to replace my batteries here. Give me a moment. Hello, Espa. Okay, let me replace my batteries here for my. Okay, good. Okay, so yeah, this is a good reference image. So let's just use this so that we can get those texture details. So we're going to use procedural texturing here to get that material there. So let me maybe bring this into our scene. I think we need another light in front here. This time it's going to be an area light. We can try using the disk shape. Maybe reduce, give it a custom distance so that this light doesn't affect too much the backside. Okay, now let's work on the procedural textures. Let's start by working on the noise on these cracks. So create a new material and the cracks. What I'm going to do is start with the noise texture, noise texture. We're going to go through these different noise patterns and see what gives us better cracks. Will this be in the archive for later watching? Yes, it will be. It would be. Team Lindberg, thank you for being run. Yeah, it will be available. So we have this noise, and we can also try Musgrave, see the kind of pattern that we get from that. Let's see what other kind of noise we have here. I think these two can give us better results, good results for this. So if I add a convert color ramp here to get some contrast in here, just want, let's see, let's try this with this here. Just a bit of experimenting. Okay, you can see that they're being squished at around this side. That could be as a result of the scale we have for this object. But to get rid of these being squished here, we can just add texture coordinate mapping and change from generated to object, so that the scale, there is no stretching from any direction. Maybe this can be, okay, so this can be our cracks. But let's see, what do we get with this noise? Sometimes you can also experiment with just having some of this detail connected into the noise, just to see how things look. Sometimes you can get procedure texturing is about experimenting, a lot of experimenting. Sometimes you get results you didn't expect, which I think this is not too bad as well. We can use this somewhere. So let's start fitting these into different areas. Let's use a vector bump map. So this is cutting out, is pushing out instead of pushing in. So we need to invert this. So I'm just going to add a color invert here to invert those there. Maybe have larger cracks. So these are going to be our larger cracks, but they're too smooth. So what we can do is let's get this. So this is our what we have. We can use a noise texture. So texture, noise texture, and subtract it from this. So I can add a convert math node. Let's preview this. Let's try subtract. Let's can go in and add a color ramp here, or instead of a color ramp we can use a math node. Convert math, the operation of power. so we can control the noise. I think this is going to give us better cracks, as they make it makes it the crack fade in instead of being continuous. Like here, you can see all these cracks are connected. That's not what we want. You can see these cracks start breaking up in some areas. They are non-continuous. So this crack comes from here. Let me just get it comes from here, and then it fades into this side. They are not. You can see, maybe this is a good example. You can see this crack ends here. Another one. They're not continuous, super continuous as these. So adding a noise and then breaking them apart like that, yeah, gets us to this. And now we can control. We can use the scale here to add some detail into those cracks as well. So you can see now that they're not super smooth as we had them. You can even play with the detail here to make them super smooth. You can play with the distortion a bit like that. There. If we use this now, you can see what we get. Again, we have this stretching going on, and to get rid of that, we just need to use object coordinate mapping instead of generated. So I'll just connect this into there, and that should get rid of the stretching on the side here. So let's see what we have here. It does seem that we have a lot of details coming in. That don't seem to be visible here. So what I'm going to do, I don't want, I just want to have only the large cracks, not the small cracks. And see, I don't want these small details in there. So what I'm going to do is add, let me just grab these, extend them here. I'm just going to add a convert color ramp here, so that I can start cutting off some of the detail that is coming in. Just can see by just adding the color ramp there, we have already started cutting out a lot of noise that was coming in through there. That, which is great. And there we have those cracks. Now we also need the larger cracks or larger displacement detail. Maybe try and scale it and rotate it. I'm not sure what you mean. So we want to also bring in this other detail. Okay, I don't like this, so I'm just going to, I just want some bit of noise. It shouldn't be distorted at all. Again, I don't want it to be stretched here. So again, I can use this vector input we have to get rid of that. So we can mix these here. So I'll just add a convert math node to mix the two. Okay, this color ramp here is cutting off a lot of detail that I want. So what I'm going to do is mix these after that car ramp. You can see what we have now. So it seems that this noise might be a bit too large, or too small, so let's have something like this. And what we can do is now use what we have here from the normal to colorize, for the base color to colorize that. So this, and if you have the normal input, you can separate, I think it's under convert, you can separate the RGB. So bring this, it's convert, separate RGB. Future, thank you. How's your day? And the reason why I'm separating the RGB from the normal is that let me just clear the rotation for this object so that you can see what I mean. I want to get the pointy parts of this mesh, and before I even do that, let me make sure to apply the rotation of this object so that I can easily know what I'm talking, what we have here. Actually it's non-separate RGB. It's supposed to be separate X, Y, and Z from this vector, because the normal map just gets the color information and the height information and changes it into X and Y values that it uses to displace the mesh. So if you have the separate X and Y, you can get the position of different vertices and convert them into a mask. And you can see if I add a car ramp here, I can get the, I don't know if I'm explaining this better. Let me show you what I mean. Promise Namereno, your top channel 1-on-1. Can't believe how much I look forward to your videos. Thank you for that. Thank you. So what I'm trying to do here, let me get my pen tool, is this surface here, or this mesh, is in this shape. So this is the kind of cross section of this shape, and what I want to do is to get the tips, just the tips of this surface area, so that I give them a different color. And what I've done here, it's like getting the pointiness of the mesh. And what I've done here is the bump map or the normal map has that information, but you can't really just access it directly. So what I did is this information, the height position of these points here, is stored in the normal map as X and Y values. So what I did is separate that information into X and Y values so that I can just find the Z values, and I can use this color ramp to isolate the pointy parts of that mesh. The issue is it doesn't isolate all these sides, because their normals are pointing the opposite direction. They're pointing this side instead of that side. So the best way to do that without using this would just to use the input geometry info and I use the pointness map. Yes, see if I can find it. This pointness map, but the problem is it doesn't work with Eevee. You have to switch to cycles, and it would give you a better, better results than what I'm trying to use here. And it will also give you these back details. So the problem is that if I try to do this live streaming, my OBS would really be laggy. I'm not sure. Okay, it seems to be okay here. But again, I want to work in cycles in Eevee because it's much faster than Eevee. So that is why I'm approaching this this way. And we are going to get nearly the same results. But for you, you can just use the pointness node instead of Eevee. So I want those points. So let's just let's start coloring, giving these some color. So the points are going to be browner, or I mean washed out like that, and then we can have sampling different colors here. I can also have this color ramp, colorize it as well. Okay, so we can't see the details very clearly here. So what I'm going to do is add a math node, change the operation to power, so that I can make the details more pronounced. These are supposed to be our cracks, but I think we are losing a lot of detail with this color ramp, so I'm just going to remove it for now.